we go. Okay, welcome back to statistics. We're still doing our homework walkthrough here. I'm sorry it's taking so long to get through this, but this should be our final installment for 3.2. I hope it doesn't take you nearly as long as it's taken me. I've got a little bit of an excuse, but hopefully chapter 3, this does tend to be a little bit longer. The rest of the homework for the rest of the sections, there's a lot of data entry for some of them, but the early chapters tend to be the worst part of it. So let me go ahead and share the screen. Okay, so we have that, and I think we were back here. We were looking at something like this, and we were trying to figure out the coefficient of variation. I'm not a big fan of coefficient of variation, and I'll show you why. Okay, so this is my guy here. Okay, coefficient of variation is another one of those formulas. I don't like these questions, so I generally don't have people memorize this particular formula. But coefficient of variation is simply the sigma divided by the mean, or Sx divided by x bar. I kind of try to group it so we have hold on a second here. Pause. Okay, I had to sneeze. I'm sorry. Try to group them so that we have parameters. So we have population standard deviation over population mean, sample standard deviation over sample mean. Okay, so that's generally how I try to group them to remember them, but I don't think that's necessarily a thing that we have to deal with. The reason I don't like this particular measure is that standard deviations it is possible to have a standard deviation of 0. Okay, and what that would look like if your standard deviation is 0 or your sigma is equal to 0, what your data set's going to look like is like 7, 7, 7, 7, 7, 7, da, 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 da. So it is possible for the mean to be 7, but the standard deviation to be 0. But so technically it can be 0. Okay, I could pick any other number. Like if all of your data happens to be 10, 10, 10, 10, and all of your data happens to be 10, your standard deviation is also going to be 0. Okay, and it doesn't matter. Just pick a number. So the standard deviation of a constant is going to be 0. So if you're a math person and you have a standard deviation of 0 and you happen to have every measure is pi, 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 etc. Okay, so as scary of a number as you can think of, if as long as it's the same one, that standard deviation is going to be 0. The average is going to be pi. Okay, so the reason I don't like that is because standard deviation is unlikely for standard deviation to be 0. It's possible, but it's unlikely. Most examples don't have a standard deviation of 0. But it is possible and frequently happens that the average is 0. Okay, so the reason I don't like this particular measure is that it's entirely possible. Like, what happens if your what happens if your average is 0? Okay, it's the same reason if you're in finance and you have PE ratios, profit to earnings ratios. Okay, like what happens like when Amazon first started, right? It did not, our price to earnings ratio, the stock price would go nuts, but the earnings, like it didn't make any. The first 10 years Amazon existed, it didn't make any money. The earnings were 0. So this is not an expression you want to deal with. Okay, in math, you don't want the denominators to be 0. Okay, if they get close to 0, what happens to your price to your ratio? It does something like that. That's it. If earnings get close to 0, so if your average is close to 0, it's going to look something like this. But if it is 0, then it's undefined and it's nonsense. You don't really have anything you can work with. So let me just go through my little preamble about why I don't like this particular measure. So I'm not keen on picking a problem that's going to have this. So if you don't remember this formula, it's not going to be the end of the world. If I do go out of my way to put one on here, I'll try to tell you that, hey, I picked one, but I generally don't like this particular measure simply because it's very possible that you'll see very often that the standard deviation is one thing, but the mean can be 0. Okay, so that's just how that works. Say, how could the mean be zero? I'm like, well, think about temperatures, right? You can have an average temperature of zero. I mean, not in Albuquerque, but it's possible somewhere else to have an average temperature of zero. Often we go through, or in person, we go through classes, we talk about our net worth. So if we average out all of our net worths, like I just took out a huge mortgage, mine's probably negative, right? You're a young person, you don't have a lot of credit card debt, yours is probably positive. So if we add those all up together, it's very possible we're going to get a zero for our average. So the coefficient of variation for like the class net worth is not going to be a sensical kind of a number. It's going to have a zero in the mean. It's a huge standard deviation, right? But the average the average is going to be a zero, so it's just not going to be a number that we can really use. So that's why I don't like coefficient of determination. And this might come in handy for you. I remember I interviewed for a finance job one time, and he asked, the person who interviewed me asked me like what I thought about PE ratio, price to earnings ratio. I was like, I don't like it. He's like, why? I'm like, I don't. At that time, I didn't really know why I didn't like it. It just felt like it wasn't a good measure. He was like, the reason probably is, and he pointed out, he was very kind to me about, doing out the interview. He's like, the earnings, it's possible for the earnings to be zero, and it's possible for the price not to be. And then what do you do? Like, well, we just use zero. Like, that's a terrible choice. Okay. Because as your earnings gets to be really, really tiny, your price to earnings ratio is going to shoot up to infinity. It's going to be huge, and it's not going to be a ratio or a number you can make a lot of sense out of. So I'm not really keen on this particular problem, but they give us a couple other problems, so we'll go ahead and do a couple just to kind of figure out what's going on here. So let's see, we have a standard, we have a scores for statistics exams, has a mean, has an average of 81, sums on a calculus. Okay, they give us a couple of things. Mean of standard deviation, okay, mean of 81 and a standard deviation of 10. So the coefficient of variation, we have mean is equal to 81, standard deviation is equal to the first problem here, it looks like it was what, 10? It's 10. And this is for stats. Notice we're not being particular about sample standard deviation versus population standard deviation. They're just saying what it is. So that's not part of the problem. Okay, they're not trying to trick us on is it population or sample. They're just telling us these are the values we want you to use. Go ahead and use them. And I think that's a fair way to pitch that question to you. So we have 65 and a standard deviation of 11. So 65 and 11. All I want you to do is just take our coefficient of variation, and we're just going to take our x bar divided by sigma, or here, or s rather, and mu over sigma. Either way, okay, and that's all they want us to do with that. So we'll go ahead and type in a couple of problems here. So let's see, they want the very standard, the coefficient of variation for the stats exam. So we'll go back to our calculator here. So the stats exam, that's just going to be, it looks like, get this out of the way here. So it looks like this is going to be 81 over 10. So that should be like 8.1 or something. So 1 over 10. So it should be 8.1. So there we go. Okay. And then 65 over 11. I'm not going to do that in my head. Okay. It's 6-ish, but I'm not gonna swear to it. Okay, so I want 8.1 here. 8.1. Okay. Fingers crossed that I typed this incorrectly. Okay, it did not like this. Coefficient of variation. Let's see. Should be x bar over. Oh no, it isn't. I'm sorry. I got this mixed up. I got it backwards. Because I went through this whole thing talking about this, the mean to be zero, and then I swapped it in my head. So it's sigma over s over x bar. Okay, or it's s over x bar or s over mean. So I got it mixed up. So I went through the whole thing and then said I'm just going to toss that out and not worry about it. So I went the upside down. Okay, I don't want that either. I didn't want squared. I want 10 over 81. 81. Okay, so I hope you guys can forgive me for that. A 10 over 81. How many decimal places do they want here? 2 decimal places. So we're going to say 0.12. So 0.12. And when we check it, and let's see. Okay, that's much better. Okay, coefficient of variation for the calculus exam. So we are going to want our standard deviation over our mean. So we have standard deviation over our mean. So that's going to be it's 11 over 65. Trust me, a mean for calculus exam could be 0 too. It's not pretty, but it does happen. Okay. Hopefully we'll not have that problem. So the 2 decimal places on this 9 is going to turn this 6 into a 7. So I'm going to say this is 0.17 here, okay? So we're going to go ahead and double check that. So we're going to say 0.17, and we'll check that. Okay, yay, and then we're good to go. Which one had the greater spread relative to their mean? And that's really what we're doing here. Like the larger coefficient of variation is going to give you a larger spread, right? Because it's, as we have S over the mean equals some kind of coefficient of variation. So if I multiply this, so this is standard deviation, S equals mu times the coefficient of variation. So if this is a bigger number, right, mean times coefficient of variation, if this is a bigger number, we've got a bigger spread. That's all that's going on here. Okay, so we'll just go ahead and do that, and we'll say we have a bigger spread. Right? So it looks like the calculus exam had a bigger spread here. So calculus had a bigger spread. All right, and then we should be okay to go with that. Okay, I'm not too happy about these particular questions. So I feel like I'm not going to memorize that. Okay, I'll forgive. Okay, what value is 1? Okay, now we get into something that's going to be a little bit more useful. What value is 1.5 standard deviations below the mean? Okay, so remember our z-score. Okay, x minus mu divided by sigma. Okay, and they want to know 1.5 below. So what I'm going to do is I'm just going to solve this for x and see what happens here. Okay, I'm not going to do too many of these, and you can memorize this formula, although I would suggest memorizing this guy and then working it out. Okay, and I'll show you a little trick for it. So we have x is minus mu is equal to, right, multiply both sides by sigma, multiply both sides by sigma. So we have sigma z, and then add both sides. So we're going to say add both sides, add mu to both sides. So we have x equals sigma z plus mu. Okay, and you can say z sigma. Okay, it doesn't matter which way you do it. And I'll ask you, because we're face to face, I would ask you guys, have you ever seen a formula that sounds like or has the rhythm of x equals sigma z plus mu? A lot of times students are like, no, they've never heard that before. I'm like, well, what about y equals mx plus b? It's the same idea. Okay, so all we've been doing with these z formulas or these z-scores is tricking you into solving lines. Okay, I mean, the letters are different, it's spelled differently, but this idea of mx plus b is still there. You just have to remember, like, oh, instead of m, it's the sigma, so it's the standard deviation, the slope. The variable is now z instead of x, and then the intercept is going to be b. Okay, so that's all we do with that. So it's okay. We could, as long as we remember, we have z equals, okay, and then we could write this down. So we want we have a mean of 37 and a standard deviation of 6. So we want x minus, what was it, 37? 37 over 6. And they want to know which 1.5 standard deviations below the mean. So that's going to be a negative number. So we want negative 1.5 equals x minus 37 divided by 6. And all we're going to do is we're going to solve for x. So multiply both sides times 6. Okay, multiply both sides by 6. So that's going to be what? That's going to be negative 9 equals x minus 37. and then add 37 to both sides, add 37 to both sides. I'm embarrassed about this. So 37 minus 9 should be 28, I think. But that's all squared out. Like 28. Okay, and that's going to be our value. So 1.5 standard deviations below the mean is a 28. Is it below the mean? Sure is. Okay, remember it said, oh, mean is 37. We got 28. That's not good. Okay, so that's our value for that one. So fingers crossed, and then we can move on. Okay, what are the values? 3 standard deviations from the mean. Okay, and in this case, it doesn't say positive or negative. It just says 3, plus or minus. So we have to do both sides here. So we're going to say x minus 37 divided by 6 equals -3, and we're going to just solve that. So multiply both sides, right? So we have x minus 37 equals 18. Add 37 to both sides, add 37 to both sides. That's positive. That's the positive side. So I just did plus here. So what do we have here? Looks like we have 45. So we have 5. We'll carry the 1. So that's 45. So the upper value is going to be 45. And then we have x minus 37 over 6 equals -3, because we have with ends. We have -18. So we have x minus 37 equals -18. And then we have to add 37 to both sides, add 37 to both sides. Okay, and again, bad about the fact that I would have to use a calculator for this, but pretty much 37, but it's 37, right? -18, carry the 1 here, so that's going to be a 9. I like 19, -19. So we're going to be going from -19 to what's this over here, 45. So -19 to 45. Okay, and that should be our setup here. Hopefully I did my arithmetic correctly. Okay, we'll see. Okay. So we have -19 and 45. My fingers are crossed. I'm hoping I did that right. Both of them are wrong. Okay. 3 standard deviations from the mean. Let's double check this guy and do it again. So we have x minus 37 over 6. And then we'll double check the original problem and say, let's see, mean, okay, 37, and then we have 6, okay, and then we want 1.3 standard deviations, so we want 3 up here, okay. So we're just going to double check this, make sure it works. So 3, and then we have x minus 37 over 6 equals -3. So we're just going to be more careful and use the calculator this time. I apologize, I shouldn't have to use calculator, but x minus 37 equals 18. Okay, so we have 18 and 37. Okay, so 18 plus 37. 55. Carry the 1. Okay, and then here we have x minus 37 equals -18. Add 37 to both sides. Add 37 to both sides. So I want 37 minus 18. So again, we're going to double check 37 minus 18. All right, we got 19. So we have 19 to 55. Okay, so we'll double check this one and hope for the best on that. Okay, so we have, okay. Yeah, there we go. Okay, so what are we looking at here? We're looking at, I want 19 and 55. Okay, I was off. 19 and 55. Okay, so there we go. We'll recheck. Okay, that looks a lot better. I like the green question mark. So I got some work to do on my arithmetic. So sorry about that. Hopefully that'll work out a little bit better. I'll get more practice. You'll get more practice. And don't be afraid to use the calculator. Okay, that's especially on an exam, use the calculator. Okay, you don't have to do anything else with that. So this, okay, we'll look at number 11 here. A survey was taken in which people were asked how many siblings they had. Here's our data display, one variable stats. We have some values here. Is this a population or a sample? Okay, a survey was taken in which people were asked how many siblings they have. They asked 10 people, right? N is 10. I am sure that there are more than 10 people that have siblings. Okay, so I would say this is a sample because they did, N would be a lot bigger, right? The number of people they asked would have to be a lot bigger to get a population here. There's a lot of people in the world. So we're going to say there's a sample. Okay, so we have that. We'll check. Okay, and then, yay, we got agreed. And then is the appropriate standard deviation. I would, since we used a sample, I want to use S. Okay, so I want this 0.9189 kind of business here. So we're going to say 0 point, and then we'll just calculate, we'll just break this down. 9189, 9191, where are we? 9, nope, 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 I don't want that at all. 9189. Okay, I wonder how many decimals they actually want us to go through. They said write down all of them. So 9189, and what do we have here? 365, 365, 365. Okay, and then 834, 834. You could probably get away with fewer, but oops, I want 834. So we'll check. We'll check that. Yay, we did that. And then what is the appropriate variance? All we're going to do is take this number here and square it. Okay, did they tell us the squared? No, they did not. So we're just going to take our sample standard deviation and square it. So we went 0.9189. And I'm not going to write down the whole thing. So 0.9189. And we're going to square it to see what the variance is. And we're just going to write that down. So 0.844. I'm gonna round this 7 and make the 3 to a 4. So we're going to say 0.8444, and we'll see what we get here. Okay, so 0.8444, and fingers are crossed because I don't know what they're gonna. Oh, they went 7 decimal places. Good Lord. Okay, that's not gonna work out too well. So we gotta keep going. Okay, we gotta keep going. So we want 0.9189. Let's see, 9189, 365, 365. Okay, 834, 834. Okay, squared. Take that in. Oh, we still got, okay, to 7 decimal places. It looks like those 4s would have been just fine. So we'll just keep it. We'll put in some extra 4s because I have a feeling that's what they're going to want here. So 4, 4. So that should be a whole bunch. We'll check. They didn't like that. Let's try one more. Okay, there we go. So that's, we just have to count to 7. Okay, that's what we're trying to do with that one. That seems like a picky problem, but it seems okay. That's what they want. That's fine. But that's what you do. Okay, so just remember, variance is standard deviation squared. Right? Is empirical rule okay? All we're looking for is this bell-shaped and kind of symmetric. It sure is. So we have a bell-shaped distribution here. So following this, which standard deviation is, can we use the empirical rule? We will probably be able to use the empirical rule. If you have a skewed distribution, you don't want to do that, but otherwise we'll be okay. Okay, proportion of data between 23 and 47 is approximately, so let's see, like how, we have to check how many standard deviations down and how many standard deviations up are they. So let's go ahead and write some numbers down here. Okay, so it looks like we have a mean of 35, standard deviation of 12. So we have a mean 35, standard deviation of 12. Okay, double checking, sure is. And now we're going to check, they say they wanted us to check what? They wanted 23 and 47. So we're going to say x minus mu divided by sigma. That's our z-score. Okay. So we're just going to see, let's check to see. They want to know what percentage of the data is within 23 and 47. Okay, so we're going to say 23 and 47. Okay, and then our average was 35, so 23 minus 35 divided by 12. 47 minus 35 divided by 12. Well, excuse me, I will use the calculator for this because I do not trust myself to say. This is just 12 over 12, isn't it? So that's just be 1. So we're going to double check ourselves. 47 minus, okay, 35. There we go. That's 12. 12 over 12 is 1. I will bet that this is going to be -1, so 23 minus 35. That seems like it's a -12 there. Divided by 12, this is -1. So how much data is within -1 and +1? This is the kind of question I'd probably ask you. Okay. So I want 68% because it's within 1 standard deviation. So it's 1 standard deviation from the mean. Okay. So we'll check, say, hooray, we've got that. So that should do it. Okay. So that should, I don't think there's a next. I think we're good. So that should wrap up our 3.2. Okay, hopefully you did that in a faster time than I did, but if you didn't, that's kind of the walkthrough. And the next video we'll start on 3.4. So thank you very much for showing up or for tuning in, and I will see you in the next video. Thank you.